Question 18, worksheet forces on threaded ring. A ring of mass 4 kg is threaded on a smooth circular rigid wire. Okay, so that would mean that we have a weight in this direction, which would be equals to 40 newtons. Okay. The wire is fixed in a vertical plane and the ring is kept at rest by a light string connected to a, okay, since there's a string connected to the particle, there's going to be tension. And we know that the tension is always away from the mass. So here's the tension in the string. Okay. And since this ring is making contact with the circular rod, there's also going to be normal contact force. And normal contact force is perpendicular to the contact. And since it's a circle, the contact would be tangent. So somewhere on this line. And because of that, the normal contact force would be perpendicular to it. So somewhere over here. Also notice since this is a circle, we know that radius and perpendicular are also tangent. So we will also get a straight line coming from the point C downwards. So this would be R exactly here. Okay. So there are three forces acting on the mass. There's tension, there's normal contact force, and there's the 40 Newton weight. There's no fourth force acting. That means we can use Lemmy's theorem, which says that if you have three forces and the three angles opposite to those forces, you should be able to apply Lemmy's theorem, which would be T upon the angle opposite to T. Where's the angle opposite to T? Let's point it out. Opposite to T, we have R and 40. So this would be the angle opposite to T. Let me call it theta 1. So T1 upon sine theta 1 is equals to, if R is the second force we're taking, what's the angle opposite to R? Okay, so opposite to R, we have two forces, the T Newton force and the 40 Newton force. So and the angle between them is this angle. This would be theta 2. So R upon sine theta 2 is equals to 40 upon, okay, the forces opposite to 40 newtons are R and T. So theta 3 is the angle between R and T. This would be theta 3. Okay. Now we have to determine these angles and then substitute the values of the angle there. Okay, let's see. So what do we know since this is an isosceles triangle, this one? So we have these forces inside this triangle. We have a 25 degrees here. And we have a 180 minus 50, which is what, 120? 180 minus 50 is, oops, 130. So this is 130 degree. Okay, now how can I find the other forces? We know that there are a few 90-degree angles here. Where are those? This would be a 90-degree angle. Okay. And this would be a 90-degree angle. And the two angles opposite to that. Okay. So that would be a 90-degree angle as well. So I have part of the purple angle. I have this angle. And this would be 90 minus 25. Which would be 65. So we have a 65 degree here, and the rest of the purple angle is 90. So we have 65 plus 90, which is what, 155. So the purple angle, which is theta 3, is 155. Okay. What else do we have? Okay. So if I extend this triangle downwards, I should be able to find a few more angles. And let me make a horizontal line here as well. Okay, this should help us in finding a few more angles. Okay, if that upper angle is 130, then this would be 180 minus 130, which would be 50. Okay, that would make this angle 180 minus 50 minus, there's a 90 here in this triangle as well. So this would be 40. Okay. And then this would be 40 as well from alternate angles, because see, we're getting alternate angles. Let me show you. These two lines are parallel lines, and then there's a transversal in between. So we have 40 here, and if that's 40, then 90 minus 40 is 50, so that the blue angle, this angle here is 50 degrees. So theta 1 is 50. Okay. Now we need theta 2. So we can just do 360 minus the other two angles. 360 minus 155 minus 50. 155 again. So this also comes out to be 155. So that means theta 2 is also 155. So now I have the value of r. If we look at these two fractions, sine 155 will get cancelled and r is equals to 40 newtons. Okay. Now we look at the first fraction and the second fraction, and that should give us the value of T1, which should come out to be 72.5 newtons after rounding.